నమస్కారం. డాక్టర్ బిఆర్ అంబేద్కర్ సార్వత్రిక విశ్వవిద్యాలయం విద్యార్థులకు స్వాగతం. ఈ ప్రసారంలో
we are going to discuss about the description of sedimentary rocks. Sedimentary rocks, which are otherwise called as secondary rocks, and these secondary rocks have covered nearly about 75% of the Earth planet. In view of its larger coverage over the Earth planet, there is very importance to the study of sedimentary rocks. The sedimentary rocks are derived either from the igneous rocks or from the metamorphic rocks. The igneous rocks and the metamorphic rocks, when they are exposed to the atmosphere under normal temperature pressure conditions, lot of geological events will act over it. Because of the geological event action over the pre-existing rocks under normal temperature and pressure conditions, some other rock will derive from both igneous and metamorphic, and the resultant rock which is derived due to secondary process is otherwise called as a secondary rock or a sedimentary rock. And today we discuss about the origin of a sedimentary rock, its characters in terms of textures, structures, classification, and the description of a couple of sedimentary rocks. And at the beginning we discuss how a sedimentary rock is derived. The formation or the genesis of sedimentary rock takes place in 4 or 5 stages, and those 4 or 5 stages are: 1. Erosion or denudation of the pre-existing rocks. The eroded material then will be transported. Erosion, transportation, deposition, then lithification and diagenesis. These are the 5 stages how a sedimentary rock is being derived. We discuss topic by topic. Weathering, as we already know in our previous years, weathering is tearing away of material. The pre-existing rocks like the igneous and metamorphic, when they are exposed to the geological action or geological agents influence, they will be subjected to physical weathering and the chemical decomposition. During the physical weathering, mechanical breaking down of the previous rocks takes place, resulting into weathered debris. This takes place either through frost action in areas of high altitudes or in extreme climatic conditions where the diurnal temperature variations are very high. The weathering process named as exfoliation takes place. The exfoliation will result into spheroidal weathering. In the same way, plants and animals and at the same time gravity will also act in terms of physical weathering, and by means of this physical weathering some weathered debris or weathered material will result in. The same way, the chemical decomposition will take place by means of oxidation. Through oxidation, iron oxides do generate. Hematite will result into limonite and siderite, leaving yellowish brownish soil cap over the pre-existing rocks. Then the second one is carbonation. The first one is oxidation, carbonation, hydration and solution. These are the different chemical decomposition process which takes place over the pre-existing rocks. Because of hydration, a lot of feldspathic materials from rocks like granites and basalts will yield into soil substance. Soil material will arrive from the hydration process. The same way, laterite, bauxites will also form. Primarily by means of solution, feldspathic materials will result into soil substances. This is how, by means of physical weathering and chemical decomposition, weathered debris will form. And this weathered material resulted from the pre-existing rocks will get transported by the geological agents. The geological agents like air, water, ice will move the material from one place to the other. The transportation largely takes place by means of water source. In water, the transportation of the material takes place in different stages. Some material will roll over the bottom of the river waters, that means on the bed or floor of the river. Then some material will float over the water body, some will dissolve in water and move transported, and some will in the form of suspension state will move from one place to the other. This is how the process of transportation of weathered material takes place. After weathering, the weathered material will ultimately get into a basin where the process of deposition takes place. The deposition takes place as and when the load of the material gets increased, or the velocity of the transporting medium gets decreased, or by means of physical and chemical activities. When there are different mediums of densities, the physico-chemical activity or the process of flocculation takes place and the entire material gets deposited. And this deposited material will subjected to the fourth step, lithification. And the process of lithification includes or comprise of compaction, cohesion. The compaction and cohesion takes place by means either by means of pressure. The pressure of the overburden will lessen the volume of weathered material and it becomes compacted, and the compactness further takes place either by means of induration. When the rocks are of soft category, induration, because of induration and because of cementing material like the silica, like the calcareous substance and iron oxides will combine the grains together and the material will be gets compacted. This is how the process of lithification takes place. Under or during lithification process at low temperature and pressure conditions, the sedimentary debris will transform into a rock, and this rock is called as a sedimentary rock or secondary rock. The process that takes place either during lithification or after lithification is called as diagenesis. Once the sedimentary rocks are arrived at, and we have to understand what will be their texture and what will be their structure. The textures of sedimentary rocks can be studied in terms of their grain size, in terms of their shape and in terms of their roundness. When we think of the grain size of sedimentary rocks, and we have to classify the sedimentary rocks initially at the very first step itself into two kinds. Some sedimentary rocks will settle at the place of their formation. If the sedimentary rocks are at the location where they are formed, we call them as sedentary sedimentary rocks. If the sedimentary rock is derived after transportation, such rocks are called as transported sedimentary rocks. Based on the transporting agent or transporting medium or the geological event or the geological agent where the influence is much, sediment rocks can be classified into different categories. If the geological agent or the transporting agent is dominantly gravity, then such sedimentary rock or such sedimentary deposit is called as colluvial deposit. The colluvial sedimentary rock can be said as colluvial if the transporting agent is gravity, and we can say example as a talus and scree for that. Then if the transporting agent is wind, we call the deposit as aeolian deposit, and example is sand dune. If it is due to river water, we call it as fluvial, and the example is alluvium. If it is due to lakes, we call such deposit as lacustrine, and the example is salt deposit. In the transporting process, the seas or ocean waves will also act. The tides of seas and ocean will also move the material from one place to the other. Such a type of transporting medium, if it occurs, we call the deposit as marine, and the example is beach deposits. This is how we have to classify the sedimentary rocks into different categories based upon the transporting medium. Then in terms of size, if we think of the mineral grain size, which is largely making a sedimentary rock, we can classify the sedimentary rocks into different categories, and they are largely sedimentary rocks. We classify them into two kinds. One is clastic or detrital, and the other one is non-clastic or non-detrital. Materials like sandstones, shales, conglomerates belongs to the category detrital or clastic rocks. By means of clastic or by means of detrital formations, wherein the mechanical breaking down and transportation, both the activities takes place and forms sandstones, then conglomerates and shales. These materials we call as stable minerals, or comparatively they are fixed or stable minerals when compared to non-detrital or non-clastic. The non-clastic or non-detrital minerals or rocks includes chet, flint, coal seams and limestones, etc. These belong to the non-clastic or non-detrital ones. As we are discussing that grain size decides the type of sedimentary rock. If the grain size of a sedimentary rock is more than 2 mm on an average, if the grain size, individual grain size of a mineral that making sedimentary rock is more than 2 mm and ranges up to 256 mm, we call them as pebbles. The mineral constituents are called as pebbles, cobbles, gravel, etc. And this rock is called as rudiceous rock. Broadly, based on grain size, we categorize the sedimentary rocks into rudiceous rocks, arenaceous rocks, siltstone and argillaceous rocks. If the grain size of individual mineral grain is more than 2 mm, it is called as rudiceous rock. If the grain size is in between 1/16 mm and up to 2 mm, we call it as a sandstone or arenaceous rock. It is called as arenaceous rock, and the example is sandstone. If it is less than 1/16 mm and up to 1/256 mm, then we call it as a siltstone. Then if it is further less than 1/256 mm, we call it as argillaceous rock, and the important example is shale. Broadly, as per some classifications, sediment rocks based on grain size are of three kinds only: rudiceous, arenaceous and argillaceous. Example for rudiceous is conglomerate, where broadly the size of the individual grain is pebble size or gravel size. If it is a sand sized grains, if a rock is made up of, we call it as arenaceous rock. If it is a fine clay sized particle, we call it as argillaceous rock, and the example is shale. Then based on in the texture context itself, based on the shape of the grain, based on the shape of the individual grain or mineral grain, we can classify the sediment rocks into tabular or flaky. If the mineral grain is thin laminae like chlorite, biotite, mica flake, etc., that is one shape, and some are having prismatic shape like topaz, tourmaline, etc. They are having some prismatic shape, and some minerals are rod like. This is how, based on the shape, minerals are classified into different kinds, and based on roundness also, sedimentary grains or sedimentary mineral grains can be classified into subangular, angular, subrounded, rounded, well rounded, etc. This is how the texture of sediment rocks can be understood. When compared to igneous rocks, the sedimentary rock characteristics are to be viewed very importantly or very seriously in terms of their structures. And as already discussed in our igneous petrology. It is always difficult to make a distinction between the texture and structure. Here also the large scale appearance of a rock in a sedimentary rock can be said as its structure. Compared to the igneous rocks, the structures which exhibits in the important characteristic of a sediment rock, which is as we discussed during our rock cycle, sediment rocks are having some important characteristics. They are loose and soft. They are having an important property which is depicted in their structures, that is stratification or bedding. In bedding or stratification, the thin laminae of sediment will deposit one over the other. This kind of arrangement of bed arrangement or sequential formation of layer by layer sediment, which is bedding, we call it as bedding or stratification, like the pages of a book. Like we see the pages of a book, in terms of sediment rock also the deposition takes place layer by layer, and each layer we call as bed. A couple of beds which are having more or less similar characteristics can be said as a formation. So, sediment rock is having important behavior or character called as stratification or layered arrangement. And one more important character of a sediment rock is it consists of or comprises of fossils, whereas in igneous rocks they are completely devoid, there is no presence of fossils. In sediment rock the important character is presence of fossils. So, in structure we see some different arrangement of beds. If beds are arranged one above the other parallelly, the layer or imaginary plane which separates the beds one over the other can be said as a bedding plane. If beds in a formation are parallel to one another, we call it as concordant formation or concordant bedding. If beds makes an angle with one another, we call it as a discordant bedding or a discordant formation. If we think of taking a differently sized particles, if we consider gravel, a mixture is having gravel, sand and clay. This is being carried over by the river waters. When it enters into a basin when the water having a mixture of gravel, sand and clay enters into a basin, what happens is, since the gravel is having high density, higher weight, it gets deposited first, followed by sand grains and followed by clay. If the individual grain mixtures are separated, we call it as a sorting, and this kind of arrangement of grains in accordance to their specific gravity, in accordance to their size and density, such type of bedding is called as graded bedding. In sedimentary rocks, this is also an important structure, graded bedding as an important structure. Then, and we already discussed about concordant bedding. Sometimes layers will make angle with one another, such type of bedding is called as cross bedding. Examples for cross beddings are current bedding and torrential bedding. Current bedding, the best example for current bedding is formation of deltas. Formation of deltas is a typical example for current bedding. In current bedding, what happens is a overlying parallel bed and underlying parallel bed. In between, the bed makes an angle to the overlying and underlying. And this kind of formation is best represented in the delta formation. The deltas consist of three beds or three layers called as the top set beds, the bottom set beds and the foreset beds. In the deltaic structure, the top set bed and bottom set bed are more or less in accordance with the gradient wherein a formation is making into a marine basin. Whereas the in between one, the foreset bed makes lot of inclination with that of top set bed and the foreset bed. When we think of the sediment rocks, we can again classify the sediment rocks into different classes, and those classes are residual deposits or residual rocks. The residual rocks are insoluble ones and are unaltered parts of rocks. The examples are terra rosa, laterite, bauxite, etc. These makes the residual group or the residual deposits or the residual rocks. The second one is the detrital rocks. Detrital rocks are otherwise or most of the times used as synonymous to sedimentary rocks. The example conglomerates, breccias, sandstone, shale, etc. Another kind of classification is chemical deposits. If physical chemical processes like precipitation, evaporation involves in the formation of a sedimentary rock, we call such deposits as chemical deposits. Under chemical deposits, we view concretions and secretions. Concretions are different from secretions. A concretion is one wherein some nucleus will be there, some dust particle will be there, some size, any small sized particle will be there, it will act as a nucleus. Around that the sedimentary formation will deposit and we call it as a concretion. A secretion is different, wherein in between grains some secretions will be filled in, and such filling in pore spaces or vesicles of grains are called as secretions. Extremely fine material will also present in sedimentary matter. We call such matter as some colloid. Colloids are of two kinds, sols and gels. If it is wet in condition, we call the colloid as sol, and if it becomes somewhat rigid or solid, we call it as gel. Then finally, we have to know about the individual rocks. The sedimentary rocks largely consists of only 4 or 5 kinds of rocks. Among them, one is conglomerate. As we discussed, this is having a pebble or cobble sized particle. This rock conglomerate is otherwise called as rudiceous rock. This rudiceous rock consists of pebble sized particles, hence it is called as rudiceous rock. And this is a sandstone. A sandstone, sand particles on compaction will result into a sedimentary rock known as sandstone. This is having sand grain sized particles and it is called as a arenaceous rock. And the next two are fine clay particle sized rocks. One is shale. A clay on solidification, on compaction will become a rock known as shale. Shale is called as argillaceous rock, and limestone do also form in the same way. On appearance, both the rocks shale and limestone do be the similar, but when we put some acid over the two rocks, the limestone will act vigorously, whereas shale does not offer any reaction. So, this is how we can make a difference in the two argillaceous rocks, shale and limestone. These are the three important kinds of sedimentary rocks: rudiceous, example conglomerate; arenaceous, sandstone; and argillaceous, shale and limestone.
మా కార్యక్రమాలపై మీ సూచనలు సలహాలు ఆహ్వానిస్తున్నాం. మీ సూచనలు సలహాలు మాకు తెలియచేయవలసిన చిరునామా: డైరెక్టర్, ఆడియో విజువల్ ప్రొడక్షన్ అండ్ రీసెర్చ్ సెంటర్, డాక్టర్ బిఆర్ అంబేద్కర్ ఓపెన్ యూనివర్సిటీ, ప్రొఫెసర్ జి రామరెడ్డి మార్గ్, రోడ్ నంబర్ 46, జూబ్లీ హిల్స్, హైదరాబాద్ 500033.